Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new. The promise of AI coding tools has always been about speed, efficiency, and radically accelerating development. But a recent analysis, provocatively titled The Token Trap, suggests that beneath that shiny veneer of productivity, a different reality is taking hold. Hidden costs that are scaling just as rapidly as the code itself.
And that's precisely the trap. What appears to be an initial productivity boon can quickly escalate into a significant financial drain, often unnoticed until it's already a substantial problem. The core issue, as this analysis lays out, revolves around the fundamental unit of interaction with these AI models, tokens.
Tokens. For anyone who's dabbled even slightly in large language models, that word is familiar. But the way it's framed here suggests it's more than just a pricing unit. It's a strategic liability if not managed correctly.
Exactly. Think of tokens as the atomic particles of AI interaction. Every character, every word in your code, every instruction you give, and every line of code the AI generates gets broken down into these tokens. And every single token carries a cost. The trap isn't just about paying for API calls, it's about the intricate, often opaque ways these tokens accumulate and contribute to overhead.
So it's not just the direct cost of asking the AI to write a function, but something deeper. Can you elaborate on what makes this a trap rather than just a line item on an invoice?
Well, at first glance, the per-token cost seems minuscule. We're talking fractions of a cent. For a single developer working on a small project, it's negligible. But the analysis points out that this seemingly low unit cost masks two critical factors that explode at scale: the sheer volume of tokens consumed and the often overlooked type of tokens.
The type of tokens. Is there a difference between an input token and an output token, for instance?
Absolutely. Most models price input tokens differently from output tokens. Input tokens are the context you provide, your existing code, your prompt, the problem description. Output tokens are the AI's response, the generated code, comments, or explanations. Generally, output tokens are more expensive because they represent the model's work. The trap emerges because as code bases grow and as developers increasingly rely on AI for complex tasks, the amount of input context required for the AI to generate useful output expands dramatically.
So if a developer is trying to fix a bug in a large module, they might feed the AI hundreds or thousands of lines of existing code just so it understands the context. And they're paying for all of that even before it writes a single new line.
Precisely. That's one of the primary mechanisms of the token trap. The larger the context window needed for the AI to perform effectively, the more input tokens you're burning. And these aren't just one-off costs. Imagine a developer refining a prompt, trying different approaches, asking for multiple iterations. Each iteration resends that large context, multiplying the token consumption. The analysis highlights that for some complex tasks, the input tokens can vastly outweigh the output tokens, driving up costs without generating a proportional amount of new code.
It's like paying for the AI to reread the entire textbook every time a question is asked.
A very apt analogy. And it doesn't stop there. The choice of AI model also plays a crucial role. More capable, higher-performing models, like the latest iterations of GPT-4, often come with significantly higher token costs than smaller, less sophisticated models. While they might produce better code, the cost differential can be substantial, especially when multiplied across an entire engineering team. The trap element here is that the initial perceived productivity boost from a powerful model can overshadow its long-term cost implications if not carefully managed.
So the immediate gratification of a superior AI output might be setting organizations up for a much larger bill down the line. It sounds like there's a trade-off that many might not be fully appreciating.
Indeed, the analysis suggests that many companies jump straight to the most powerful models for all tasks, assuming the quality justifies the cost. But a more nuanced approach, where simpler tasks are routed to cheaper, smaller models, could yield significant savings. This requires a level of architectural foresight that isn't always present in the rush to integrate AI tools.
Beyond the direct API costs, what other hidden expenses does the token trap identify? Because it seems like the financial ledger is only part of the story.
That's a critical point. The analysis emphasizes that the true cost extends far beyond the API bill. One major area is human review time. While AI can generate code incredibly fast, that code still needs to be reviewed, debugged, and integrated by human developers. The report notes that AI-generated code, while often syntactically correct, might not always align with an organization's specific architectural patterns, coding standards, or performance requirements.
So developers are spending time refactoring or even completely rewriting AI-generated code, essentially paying twice, once for the AI to write it and again for a human to fix it.
Precisely. This refactoring tax is a significant hidden cost. If the AI is generating code that's consistently good enough but not great, the cumulative time spent by human developers bringing it up to standard can negate much of the initial productivity gain. The report even suggests that in some cases, developers might spend more time reviewing and tweaking AI-generated code than they would have writing it from scratch, especially for complex or highly specialized components.
That's a pretty stark indictment of the faster coding promise. It implies a potential illusion of speed rather than genuine acceleration.
It does. And another hidden cost identified is the increased cognitive load on developers. When relying heavily on AI, developers shift from being primary creators to becoming more like editors or orchestrators. This requires a different skill set and can introduce new forms of mental fatigue. They need to understand not only the code, but also how to prompt the AI effectively, how to critically evaluate its output, and how to manage the interaction loop. This can lead to what the report terms prompt engineering burnout, a hidden toll on human capital.
So the trap isn't just financial, but also impacts developer well-being and the quality of the code base in less tangible ways.
Exactly. And another point to consider is the context cost on human developers. As they interact with AI tools, they're constantly feeding context to the AI, but they also need to maintain their own understanding of the larger code base, often having to refresh their memory on vast amounts of existing code to properly guide the AI or to review its output. This can fragment focus and reduce deep work, another subtle yet significant drag on productivity.
This all sounds like a management challenge as much as a technical one. How can organizations even begin to quantify these hidden costs and avoid falling deeper into this token trap?
The analysis proposes several strategies. First, rigorous monitoring and analytics of token usage are crucial. Most platforms provide usage data, but organizations need to go a step further, correlating token consumption with specific projects, developer teams, and even types of tasks. This allows them to identify where tokens are being inefficiently spent.
So it's about getting granular data, not just a monthly bill.
Precisely. Second, the report advocates for what it calls smart context management. This involves training developers to be more strategic with their prompts. Instead of dumping an entire file into the AI's context, they might learn to extract only the most relevant snippets or to break down complex tasks into smaller, more manageable AI interactions. Think of it like teaching developers to trim the fat from their context windows.
Like a highly skilled surgeon, only providing the AI with the precise information it needs rather than the whole patient history for every minor procedure.
A great way to put it. Third, the report stresses the importance of model selection. Not every task requires the most advanced and therefore most expensive AI model. Simple code generation or boilerplate creation might be perfectly handled by a more cost-effective model, reserving the high-tier models for truly complex architectural challenges or bug fixes that demand deep contextual understanding. This requires an internal understanding of AI capabilities and judicious deployment.
So, a tiered approach to AI tooling, matching the tool to the task and optimizing for cost and efficiency rather than just raw power.
That's right. And finally, the analysis suggests investing in internal guidelines and best practices for AI-assisted development. This includes defining clear standards for AI-generated code, establishing review processes that account for its unique characteristics, and training developers not not just on how to use the tools, but when and why to use them, and how to critically evaluate their output. It's about cultivating a culture of intelligent AI adoption, rather than simply letting developers go wild with the new toys.
It sounds like the initial enthusiasm for AI coding tools might have overlooked some fundamental economic principles and workflow considerations. The token trap isn't just about money, it's about the sustainability of AI integration into the software development lifecycle.
That's the overarching message. It's a call for strategic thinking about AI adoption, moving beyond the initial wow factor to a more mature understanding of its total cost of ownership. Without that, the very tools designed to boost productivity could become unexpected liabilities.
So, to summarize the key takeaways from this token trap analysis, firstly, tokens are the fundamental, often underestimated unit of cost in AI coding, and their accumulation can quickly become a significant expense.
Secondly, the size of the context window and the choice of AI model are major drivers of these token costs, often consuming disproportionate resources for input rather than output.
And thirdly, the hidden costs extend far beyond direct API charges, encompassing increased human review time, refactoring efforts, and a potential shift in developer cognitive load.
Finally, effectively navigating this trap requires a multi-pronged approach: granular monitoring, strategic context management, intelligent model selection, and comprehensive developer training.
This analysis really forces a reevaluation of what efficient AI coding truly means. It makes you wonder how long it will take for organizations to fully grasp these nuances at scale.
And it raises the question of whether current AI pricing models will need to evolve to better align with the actual value generated, rather than simply counting fragmented pieces of data.
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.